All right. So, Cosmo, can I just get you to... Oh, perfect. Looks like audio is
Yeah.
working. I just wanted to do a check first, but it looks like we are good. And so, first up, we have a Klizma here who's going to give us another update on rafx.
Hello, everyone. Wanted to show some things I worked on over the winter break. So, where we last left off last month, we found a pretty big win in metal backend, and we got down to about 20 milliseconds on a simpler scene, but we still have a pretty big scalability problem. There's the shadow maps are drawn every frame, and point lights take 6 shadow maps, and we have to bind all of these when we draw. So we're kind of have a ceiling, and we were still processing every single light for every single pixel. So that's going to be a problem. So the first change is that I made was adding a shadow atlas. The idea here is that when you read, you have just one big texture, and when you write, you can do all this in one pass. This isn't necessarily faster by itself, but this is kind of setting the stage for the future where we can do some GPU driven rendering. Because as far as I know, you can't change what texture you're rendering to if it's GPU driven. A side effect of this is that now you have an upper bound of memory usage for your shadows, and it's just whatever size of atlas you pick. So this is screenshot, and here's a video. You'll see as we fly through, the shadow maps will update based on whatever light's closest to you. Here, the heuristic's really primitive. It's just enough to get going. I'll play through it one more time. You can see these shadows here are in the first room, and as we swing through, we'll end up with a different shadow being picked as the most important. So before we had a bunch of passes. Each one of these is a shadow map, and now it's just one straight shot, which is great. It's again, it's not a performance benefit, but by itself, but this is can potentially be a big benefit in the future because if this is GPU driven, then we can do GPU culling. But the this is still a lot of time spent per frame. So the additional change I've made is caching shadow maps across frames. So the general principle is simple. If the light hasn't changed, and if the things that the light is casting shadow on don't change, we don't need to redraw the shadow map. If the light moves, you have to redraw it no matter what. And if the light's not moving, you just check what's in the view of the light where we're casting the shadows. I don't have that implemented at this point because nothing in my scenes move. So it looks fine as it is now, but this is obviously something that I'll need to address in the future, which a lot of the infrastructure to do that's already there. I just don't have a scene that properly tests it. So before this change, we were at on a larger scene. This is Bistro actually. We're about 40 milliseconds per frame. And that's just with a handful of point lights. And after this change, we're over 120 frames per second um, with the same scene. So we still have the issue that we're shading every light for every pixel, and that's not scalable at all. So I've also added forward clustered lighting. The idea here is that you take your view frustum and you divide it into some sort of clustering. Some people use frustum shaped slices. Some people use AABBs. And then you make a lookup that lets you process a light just where that light might be instead of on every pixel. And the way I went was AABBs in view space because they're really fast. The code is simple. And generally, you're not changing your projection every frame. You might, but most of the time you don't. And so you can generate one time and just reuse it every frame, assuming you don't change your projection. I did want to leave some links to some papers and some slides that I found useful. I guess you could look at the video later to grab these links. The first one was the original paper, and then there's 3 sets of slides. One from Doom 2016, one from Call of Duty. I don't remember which one it was, but I think that was in 2017. And then the latest Doom Eternal. So in the rafx implementation, just a quick outline, we divide into 16 by 8 by 24 clusters. That's what Doom 2016 and 2020 do, or Doom Eternal does. And I chose AABBs. I think Doom Eternal uses frustrum, more frustrum shaped pieces. And then we make a list of all our lights in the scene. We make an AABB for each light. We do a compute pass that generates bit fields. So like every AABB light has a bit, and every AABB for a cluster has a bit field. So we just mark the bits that are represent a light is in that cluster. We have a compute pass that takes the bit field and turns it into a list per cluster. And then the render pass will look up the light list that it needs to use when it draws that pixel. So here's a video where we're culling a couple point lights. This is actually Bistro, and I'm just moving the camera around, and you can see that these wireframes are where the light can possibly affect the scene. And then these kind of tiles, this is still a clustered 3D view, but since we're in the view frustrum, we only see it as tiles. This shows where the lights are affecting the scene. This is another view. This is just showing like how many lights are in each cluster. Um, and the blue is few lights. That pure blue might be 0 lights, and then red is more lights. And then an optimization that Doom Eternal and a few others do. They hash the light list, and then I won't go into detail, but if you have a hash of the light list, then you can know you're processing the same light list on all the pixels that are being processed in the same wave, which can yield performance improvements. You can reduce the registers you need because instead of tracking the light list on every possible pixel you're processing at once, now you just have one copy of the light list you're processing at a time for a few pixels in a wave. That gets more in detail than I think I really want to go into here, but this is the hashes that would be used for the light list. So the performance result it's a pretty big win. I added just a few hundred small point lights and dropped it from 90 milliseconds to 10 milliseconds with the clustering. On a 3060 Ti, it's 37 milliseconds to 3.5 milliseconds. So it's a huge win. And to be honest, this change, it looks more intimidating than it actually is. You could do the clustering on CPU. And so at that point, and you don't need to do all the hashing. In fact, I didn't really get good results from doing that. So, and if you do this with AABBs, the math gets a lot simpler. So this doesn't have to be a really complicated thing to do, but it's still a huge win. So I wanted to show some final screenshots. Remember, the goal of these changes is to be able to load larger scenes and have it scale. So this was before, and this was the fly through with kind of the dungeon looking thing, kind of a fantasy scene, and I had to limit the size of the scene because having more than a dozen or so point lights, it just wouldn't perform well at all. And there's not much geometry here. And now I can load the whole scene and no problem. And it runs, frame cap. So that's great. For this more challenging scene, this was, it keeps the GPU pretty busy even with not a whole lot on the screen. And there are a decent amount of lights, but now we can load the whole scene and it runs pretty well. Not 120 frames a second, but it's at 1440p, but still we can hit 60, which is pretty good. And a lot more lights. There's actually about 80 spotlights in this scene. So I wanted to show some more final screenshots. You can see there's a lot more geometry in here. All the lights are on all the time. The shadow maps are being cached, so there's shadows on things. And I'll do a video fly through here, see a bit more. So this is captured from a 3060 Ti at 1440p. I don't know if it's going to come through from the compression, but there's still some aliasing in a lot of places, and that's probably the next big thing that needs to be addressed. It's just the overall image quality.
I
But
don't
at
think
this
we can see
point,
aliasing too much. I think it's compressed a little bit too much to see that.
yeah, yeah. Oh,
It just looks
uh-oh.
I think I mean, it looks pretty solid from what we can see.
Yeah, I just accidentally restarted it. I don't think there's a way
Oh yeah, to go
to
all the way through.
watch it. Yeah,
Well, while we're watching it, I think yeah, it's definitely very impressive. Like yeah, just kind of seeing how I mean like the performance improvements that you're able to make with like a full scene like this. And I mean going forward, do you see any like super large areas for other improvement in this type of in like this domain?
so I'm not sure if there's gonna be any of these like massive like 10x improvements, like switching from non-clustered to clustered. Um, unless we're talking like huge scenes, which that's not just a rendering runtime problem. That's also a how do you make the tool so you can manage authoring that much content at one time? Because this scene, honestly, it'll crush Blender if you try to load the whole thing. And I
Mm,
do have some tools that let me to load parts of the scene and work on parts of the scene at a time, which maybe that's something to show in the future. But um, yeah,
interesting.
there's definitely some big improvements still to be made. But I'd say right now the main issue is image quality, which again it's probably not coming through from the compression because the thing about PBR, and it's kind of inescapable with PBR, you get really noisy light behavior. Like whether it's because of your normal maps or if it's because of the NDF function in the lighting equation that PBR uses, it's just really prone to having speckles everywhere,
Hmm.
and you have to do something about that. And I don't have a very good approach for fixing that yet.
Are
So,
there
and that's something I didn't really realize that was, I mean, it's most games require TAA and temporal anti-aliasing, and you can't turn it off. And
hmm,
it's not just because they were lazy and didn't want to implement something else. It's because you need it. If you don't
yeah.
have it, then you're gonna get these speckles everywhere, and the image quality is gonna be terrible.
And just
And
to understand, like when you say speckles, this is the aliasing that you'd refer to resolve it, and then also like temporarily, you mean like from frame to frame. If you
yeah,
don't do this type of anti-aliasing, then it creates speckles that seem random on each frame.
yes, and it's not the edges of triangles; it's the inside of triangles,
Hmm.
because the noise is coming from your shader. So just turning on MSAA, it's not going to do anything to fix that, because MSAA it'll fix your edges,
Mm-hmm.
but it won't fix the data that's coming out of your shader.
I see.
So yeah, so here's some captures. We have 1440p at 60 frames a second. These kind of bars here, they're each frame. We're running about 15 milliseconds a frame, and in one max we're about 30 frames a second. It goes more than 30 frames a second. It's just not very stable. Like it can't stably hit 60 FPS at this point, although that might be possible in the future. And just in general, there are still some wins. Post processing is it's just pretty naive. That could be better. It's probably not going to be, you know, 10 times better like having forward cluster did, but it's still a lot to win there. And the other blocker is probably just how many vertices we have to process. There's no LODing here, and I think that occlusion culling would help. But even so, at this point, I think you can load pretty realistically sized scenes. So I'm pretty happy with where it's at right now. And I'd say at this point, image quality is the next thing that needs to be improved. So that's it for me. Let's
Awesome.
check if there's any questions.
I think yeah, we ran into some more technical difficulties during the presentation because it turns out I was streaming to the Valorant Twitch and YouTube instead of the Rust Gamedev Meetup one. So I switched over Twitch so that it's now properly on the Rust Gamedev Meetup. But I didn't change, so it's still streaming to Valorant and YouTube just so I can get like a full continuous video link. But also nobody's watching it on Valorant, so that's all fine. But I think I'm just taking a look through chat. Um, yeah, I don't think I see too much too many questions, but I think um from me, I know last month you were talking a little bit about doing like a comparison between different engines, and so has there been any like new work on that? I think this was mostly like Ren 3 and rafx kind of talking about that.
Oh, so I think that's the Blender scene of Bistro and having an export that we can all share.
Mm-hmm.
And that's out. I can drop a link in the chat. And it's possible Celia Fitzgerald will mention it too.
Perfect, sounds good. Well, in that case, I think we'll get moving on. So we'll be back in just a minute um, with Ren 3. All right, we are back with CW Fitzgerald, who's going to tell us about some updates on Ren 3.
All right, welcome. Good morning, evening, afternoon, whatever. This is going to be a little rough because unfortunately over the break I got COVID, so I was down for the count for about a week. But anyway, so the first big announcement is that after 3 long months, 0.3 is finally almost ready for release. I just have to do a bunch of documentation work, but all the code is there. I don't foresee any major changes before that comes out. So that is super exciting. The big thing I worked on the break was fixing my physically based rendering implementation. Some really silly errors in there, getting that all cleaned up, and I also vastly refactored the what I call my render routine library, um, which is all the different things that all the different parts of the render graph that go into a scene. Yeah, the idea being you can take individual parts, recombine them, modify them to have custom shaders, have custom whatever, and then you can rebuild your own render graph using those parts so that you don't have to rewrite a lot of code. The other big thing is I now have, in the before times, PBR. I basically assumed everything went through the PBR material. All of the depth processing, uh, all of the culling, all was basically tied to this PBR render routine. And of course, this doesn't work very well if you want to have custom materials or you want to somehow uh, be independent of the PBR setup. So now I have a depth. I've separated out culling, and I've also separated out depth rendering, so that depth rendering can now work with any material. And the way I did this, I think, is particularly interesting, in that I have this trait here, which is a depth renderable material, and you can specify for any material. This is able to be rendered using depth, and if you have alpha cutout, you have to give me 3 parameters as a constant. You can either have this be none, or you can have this be some, saying it's possible to do alpha cutouts. Which is an index into some context. All of my materials work on ABI. You give me some textures, you give me some data, and I tell you how I will convert those, give you those textures in the shader. There's a defined way that happens. So, as an extension of this, you can say, for this, give me the texture, the index into the texture array to read the alpha from, and give me the byte index into the data array that represents the F32 that is your alpha cutoff. So different materials have some cutoff at 0.5, some cutoff at like 0.9, depends on the thing. And then give me an offset into the byte array that represents a map3 to use as a UV transform matrix. And through this, anyone can have they can define their own way of talking to their shaders. It does not have to conform to any specific rules, and they can still use this to do depth rendering. So, yeah, and the point of this is that now this is now completely detached from any material. You can just say, hey, give me depth rendering for this material. And depth prepass and shadow maps now just work. So, all right. Then next is when I give a live demo of Bistro. It's going to be blown out because I don't have very good tone mapping right now. And there's unfortunately not very much I can do about that. But it looks okay. Yeah, it's really blown out. Anyway, if you look in RenderDoc and you adjust the values, it looks great. So let me go to this other scene, and I'm going to have to change this. So sorry, live demo, just doing everything off the thing. There will be a way of adjusting the size of directional light, the influence of directional lights at some future point. And yes, and then we just have to up this number right here. There we go. Oh, I already did. Did I commit that? I did. That's horrifying. Cool. Let me go to the other slide. Yeah. Nope, don't do that.
Nothing better in a live demo than everything going wrong, huh?
Yeah, it's fine.
Easy.
That's been my week.
Yeah.
Profile. There we go. Cool. Yeah, I'm making up for the fact that I don't have cascading shadow maps right now, and I'm in exchange exploiting the fact that my 1080 Ti is ridiculously good at rendering shadow maps. Alrighty, I hope this isn't too dark. It looks too dark. Whatever. So anyway, this is the scene that I have been showing off for quite a long time. This is from the same pack that the scene that Klezma was showing off. Though this is from Unity and his is from Unreal. But as you can tell, you may have seen some of my previous screenshots. It's hard to sort of enumerate what was wrong before. Everything just kind of looked flat. But now that I've actually fixed my PBR impl, things look a lot better. And it's very hard to describe why, mainly because I now have specular again, because the bug was basically I was treating the ambient occlusion as the roughness, and basically all of these models have had an ambient occlusion of 1. So everything was just full rough. But I think it looks very nice. And I've been staring at it for a while, so I hope you guys think it's nice too. I told you this demo was going to be a little rough. Yeah, totally. It's super easy to mess up PBR, but yeah. At some point, hopefully, we'll have cascaded shadow maps, so I don't have to pump 8K shadow maps to cover the entire scene. But we're getting there. Progress. Alrighty. One last thing, and this is actually kind of super cool to me, at least. Let us go over to Scene Viewer. Rend 3 used to basically mandate your coordinate system. If you use Rend 3, you must use a left-handed X right, Y up, Z into the screen. That was the rule. Someone was like, that's weird. Why are you forcing this on me? So I have made it so that you can change the handedness of the renderer. The renderer actually only cares about handedness. Any other adjustments you can easily do through custom projection matrices or what have you. But, and this hopefully should work, currently I'm running in right-handed mode, which is actually different from my default before. I used to run in left-handed mode. I should just be able to click the left button, and if everything goes like magic, everything will look fine. Except my mouse coordinates, or my mouse look is now the wrong way around. And look at that. Everything looks just peachy keen. I'm having trouble controlling this. There we go. So that's the other big thing is handedness. So now you can specify your own handedness. This will all gonna do a huge pass of all of my documentation. Do maybe a little bit on the website, so my website isn't as barren as it is now. And then from there we'll release 0.3 and everything will be lovely. The end.
Hey, very cool. Yeah, I love. I always love seeing like the engine stuff that's going on because it's just like so much movement happening like at that like lower level. Um, yeah, I think in chat, I mean, you answered like the questions as they came up or you commented on them, so I don't think there's too much else. Yeah, someone asked, is there a Rend 3 website?
Yes, there is. Don't look at it too hard. It's terrible.
Oh wait,
there we
that's
go.
Chrome. Oh no, did I mess it up? Is it gonna? Okay, no, okay. I just can't change tabs anymore. There we go.
What do you see as the advantage of fully supported either-handedness? The big thing is that's basically a very user space problem, right? And it's essentially not my place to be saying like this is my this is the coordinate space you must use this. I mean, imagine if Rapier said like which way the gravity had to go. There's no excuse to that. And for something like Unity or something like Unreal, they can specify their own thing because they're a big ecosystem, and can be like, my way or the highway. But Rend 3 is designed to be very unintrusive. It's like just sitting there doing the rendering for you. So specifying the handedness or forcing the handedness on users isn't great. So it also means you have to flip the winding order all the time, and you have to flip transforms. It gets messy very quickly.
Yeah, definitely something to RFC for a while and figure out what works best for everybody, kind of thing. I imagine.
Yeah.
All right. Yeah, so that's very awesome to see where Run 3 is at, and hopefully we see more progress next month.
Great, thank you.
All right, so for our last speaker today, we have Kevin here to tell us about what's been going on in the world of Graphite.
All right, so this is the conclusion of Sprint 10, which we've worked very diligently on over the past month. And we have a lot of features to show off, so we're pretty excited for this. So just in case you're not familiar with what Graphite is, we've been presenting here each month, but if you're new to the meetup, Graphite is a concept and a in-development tool for basically being a vector and raster editor for basically any sort of professional 2D content creation. So if you're currently paying for Photoshop or Illustrator, or you're using GIMP or Inkscape, then this is hopefully going to be sort of a next generation replacement for all those. Additionally, for us Rust folks, it's also kind of interesting because under the hood, it is node-based, built on basically what we're creating, which is going to be an entirely node-based language for stringing together Rust functions and creating kind of a procedural tool for generating sort of any kind of data processing, but mostly oriented towards 2D kinds of things. So you can also embed it in your game, and if you want to do procedural texturing, and then at runtime make your procedural textures generate to real textures that you use in your game. That's one use case, for example. And basically, it's just a very powerful ecosystem for node-based 2D editing and an editor experience for the user to do 2D art and 2D content creation. So yeah, updates this month. We did a big refactor, and that's important because as we move towards hopefully getting a significant increase in the number of contributors after we go public with the launch of the alpha version, we would like to have the code in a reasonable state, and it's sort of accumulated a little bit of cruft over the past almost year. And then we also completed 27 new features, and basically 27 pull requests and issues closed, so that's very exciting. So let's show this off now in the live demo. Wait, sorry, this is, let me go to localhost because the build is currently building because I just merged the last pull request a few minutes ago. So let's start off with something fresh. New document. And the first thing that we added was a help menu called About Graphite. And this just gives you a little information about when this build was created, specifically when the last commit was. So the commit was at 8:30, so 15 minutes ago in my time zone. So it localizes that time zone for you, tells you the commit hash and what branch it's built from. So if you're looking at a different branch, then it will actually show you what branch it's on. And it has some links to the website, the credits, the license, and the third-party licenses. Next up, we have a refactor that was done that basically makes it so you could potentially have multiple editors side by side and in the same web page. And it reuses the same editor backend, which is running in Rust compiled to WebAssembly, but it has different instances that use the same editor multiple times. And that's sort of just a refactor that helped generalize a lot of the code base. Yeah, and then the next, I can't show that one off, obviously, but yeah, so the next one will be, let's see, we did, oh yeah, we made the editor work with touch devices. So if I go into emulating touch input, this is the input device here, I'm now able to actually draw things. This previously was not possible because it was only using mouse input and it did not know how to process what a pointer was. It only knew what a mouse was. So yeah, going back out of that mode. Next up in the list, we have layer range selection logic moved to the editor code base. Can't really show that one either, but basically it did also make the layer range layer selection more robust. So just clicking on one layer and then holding shift and then going to the next layer, that allows you to select all the layers at once, or you can hit control, hold down control and select these layers. And if I add a bunch more, basically I can go here and hold control to continue adding to the selection. And then I can hold shift and then expand the selection from the most recently selected, or I can hit control and then control and shift, and that selects this range. So basically that's what you would expect if you're using a file explorer or any other kind of sophisticated list thing that you can select a range from. Yeah, what's up next in the list? We have the input hint system. So if you look at the footer bar, now actually we can display all the different keyboard shortcuts that you can use at this moment in time. So with the current tool selected, it's saying that you can click and drag to drag selected. So you can do that. You can also hit G, R, and S. Those are the Blender hotkeys for grab, rotate, and scale. And basically you can continue looking at all of the things in the bottom and you can do all those things. And if you hit G, for example, actually that one doesn't work. But if you start dragging, then if you hold shift, that allows you to constrain to axis and it tells you that down there. So only horizontal or vertical, or that other one was coming soon, so it doesn't work yet. But basically if you go to the different tools, it tells you all the different features and sometimes those update contextually. Okay, what's next? Oh, and also the build is live. So we'll go from localhost to master real quick. Master is available on editor.graphite.design. So feel free to pull it up in your browser at any time. So we'll just create some shapes real quick to have some layers to work with. And now, what else is next in the list? Yes, we have the outline mode. So if you just click on this button, now we can see all the layers in outline mode, which is pretty cool. It helps you sort of visualize, if you have a complex document, what's behind other things. And you can go back to layer view, to solid mode. Then we have avoid referencing documents in tabs by their index. So now these tabs actually show up based upon an ID, not an index, which is just a refactor that was important to make it so we can rearrange these without crashing the editor. We now have autosave. So what this does is if you create this document and then I close the editor and then I reopen it, this is actually stored to local storage now. So if you go to application and you go to IndexedDB, and then you can see our database here.
No
this is actually
way.
stored persistently.
That is so
So
cool.
every time you reload the application, or if the application crashes for some reason, you have your work saved.
And so when you're doing stuff with IndexedDB through Wasm, I haven't seen that done in Rust before. And so was that like difficult to implement, or are you doing that with, like on the view side, or?
So that's basically sending all the data to JavaScript, and then there's a small JavaScript function that just does the handling of the saving and the loading, and then it sends the data right back to the Rust Wasm code.
Nice, that's so cool.
Yeah, that's really exciting because now we can just reload the document at any time, and it warns you, or it brings you back your artwork basically. Another thing is now we actually warn you if you're leaving the page or if you're reloading the page, saying, "Are you sure?" That way you don't accidentally hit Control W expecting to close this tab, but Control W accidentally closes the whole browser tab. Then let's see, we have. Let's see, I'm going through the list of features. Just some small bug fixes, not worth mentioning. Some other small bug fixes that are not really worth mentioning. Some crash fixes. Yes, okay, so this one's exciting. We can now drag to rearrange layers. Previously, we were able to use the control and then the bracket keys to move a layer up and down like this. But now you can actually click on a layer or even a selection of layers. And it's very robust. We spend a lot of time making it very robust. So you can drag, and you can even have like a weird selection like this, and then they all get clumped together. A little hard to see because they all have the same layer name at the moment, but that'll be something we're working on the next few days, is adding layer names. But yeah, that works. And then let's see, what else do we have? We have a new overlay system. So basically, all of the blue the blue overlays that show you when things are selected. So all of the blue stuff that is sort of contextually showing you stuff that's not part of the actual artwork, that was refactored to now have a separate SVG. So if you're curious, we have a separate SVG on top of the other SVG. So all of this stuff is actually
Hello. All right, I don't know if you can hear me on Discord, but my Discord has also crashed from the file system. Can someone like just type in text if they can hear me on Discord? One sec, I'm just doing in restream. My Discord crashed. And I can't really fix this without rebooting. Let me see here. I'm just waiting for someone to reply from Discord. But I think Keevan's probably still talking. Oh, this is unfortunate. All right, I might have to. One sec, I can probably open Discord like on my phone or something. I apologize to anybody who's watching this stream right now. It's gotten more and more jank as we've gone on. Let me just find. Oh wait, I can show my face probably. Hey, okay, there we go. So now you know that something is working. How do I even find the server on my phone? I got way too many Discord servers. Sheesh. Okay, here, search. Game development in Rust. All right, now let me join the voice chat from here. Can you wait? Hello? Can you hear me? Okay, so I'm joining from my phone because my computer's Discord crashed, and so I think at this point, my only option is to reboot. So I might have to end the show off here. So wait, are you able to? You're not able to like see my screen on Discord anymore, right? Okay. And also it's like the last like 3 minutes where I cut out, so I apologize for that. But you know, it is the way it is. Yeah, okay. You finish wrapping up on Discord because people can still watch your stream even if mine's dead, and I'll just wrap up on Twitch. All right. Perfect. Sorry about that. I'll leave you to it. Okay, so hello again, Twitch and YouTube and all the recordings and stuff like that. So Keevan's gonna end his presentation on the Discord, and I'm going to end off the other presentation on YouTube and Twitch over here. And now, if you watch on YouTube, I will put proper timestamps to the beginning of each presentation. And so, if you, as long as you just click on like, I want to watch Ren 3 with C.W. Fitzgerald, you can get a good experience. But if you're watching this part, then you see how everything is falling apart. And just for reference, here's like the errors that start popping up for me. And so, you know, it is what it is. But I think so. I want to try and switch to. Oh God, it's gonna. Okay, cool. So I can switch to Firefox still. I do want to show off. So okay, so end of the January meetup. The Rusty Jam is, so we've been sort of in discussions about when the next meetup or when the next jam is going to happen. I think we're looking sometime in February as of right now, but before then we want to do a like icon and mascot competition for like the branding on the jam. And so to join, it's taking place on Itch starting in 6 days, and it's just like a week long. If you are an art person or you know art people, feel free to tell them about this. And so basically the the jam that we host, it has like this icon of like Ferris with like a game controller, and we want to do something a little bit different. And so now I think I'm gonna have a pretty fun time with this, because although I don't do good art, I have some like interesting styles that I've tried before, and they work pretty well, where I basically just like take an image that already exists and then do drawings on top of it, and it looks pretty cool. So I think I'm gonna try doing that in Graphite, which it'd be a pretty cool experience to see what's possible in Graphite. So I'm gonna give that a try. And then yeah, as for that, I think that pretty much leaves us off with this month's meetup. Now I think I'm probably at the point where I've experienced enough turmoil from trying to do this without preparing, like when it comes to audio issues, and now like, well, the file system today just like brought a lot of stuff down. But I think I'm gonna try my very best to invest some time into the production quality, because like I don't know, this is sort of fun to trudge through, but I can do better. It can look cooler. And so yeah, in the second year of the Rust Gamedev Meetup, hopefully we can see some cool improvements. So thank you very much for coming out today, and yeah, I guess we'll see you next month.